Alright guys, hi, Eric here again at Redmond's Performance. Today what we're going to do is we're going to go over how we balance an engine. So the other day we cut the counter throws off on that 383 stroker. I showed you how we machined the counter throws off because they were hitting the bottom of the pistons. So now today what we're going to do is we're going to run a balance on the crankshaft. Pretty sure that it's going to take Mallory inside the crank because we'd removed so much weight off of it. What Mallory is it's a heavy metal or carbide, basically. So what I'm going to do is I've already set up 3 of the bob weights. I'm going to set up 1 bob weight here with you guys, or kind of go through the theory of how the bob weight's set up, how we measure the piston, the rod bearings, how we do some of the math, and then what we're going to do is we're going to spin the crankshaft, show you how the program works. And then what we'll do is from that point in time, we'll stop this video. I'll produce another video, which will be a secondary part of this, which will be showing me installing the Mallory, how we cut the holes in the crankshaft, install the Mallory. And then after that, we'll have a third part of this video. And on the third part of the video, we'll respin the crankshaft with the bob weights back on it. And we'll show you how we hit our goal finding our balance on there. So anyway, let's kind of get started here. Kind of zoom you guys in down here on the bench. So kind of go over what's on my bench here just a little bit. I've got your basic triple beam here on the bench. I've got a gram weight scale. And then over here I run a magnetizer, demagnetizer there. Let me get this camera up a little bit, you guys. There. So anyway, what I have is, that's what I keep on the bench. Now, up here in the back, you guys are looking in the back, there's a whole bunch of washers hanging on the pegboard in the back. What we have here is we have a set of bob weights. The old way of doing bob weights, and a lot of guys still do it, and it's nothing wrong with it. It's a great way to still set up your bob weights. Right here where the washers are at, it would have a cylinder and you would fill this full of lead shot and then put a cap on it. The problem is the lead shot goes everywhere. You're stepping on little BBs, you're always cleaning those little BBs up. So what we did is we opted to use a washer system. Find that it's just a little bit cleaner and a little bit easier to use. So anyway, basically here's a bob weight, it opens and it shuts. So now let's go ahead and start measuring now. Now mind you, I've done all these measurements in advance. So a lot of this right here is just for you guys to get an idea of how everything works. So right now I have my scale zeroed out. What we're going to do is we're going to take the piston here first. And the piston right now has, there's no piston inside, or no wrist pin inside the piston. I'm going to take a measurement of it. And the piston weighs 502.9 grams. Then I'm going to measure the wrist pin, the weight, and I weigh 130.7 grams on the wrist pin. Now the next thing that we have here is we have rod bearings. Now the rod bearings, we're going to do the rod bearings by 2, okay? So what we're going to do is we're going to, these measure out at 58 grams per pair, but we're going to double this up. So that's going to give us a total of 116 here. Then what we're going to do is we're going to measure the complete ring packet. So oil control rings, scrapers, everything. Our ring packs here weighs 46.2 grams. So now that we've got the basic hard parts measured, now what we're going to do is we're going to use the triple beam. So what I'm going to do is I'm going to try to adjust you guys in so you can see how a triple beam works if you've never seen one before. So let's kind of get this in. It's a little bit hard always doing this filming at the same time, but all right, so let's see if I can zoom you guys in maybe just a little bit. All right. So what we're trying to do is we're trying to divide this rod by 2 here, okay? And that's where we use the triple beam. I'm going to re-zero my scale because I put this other piece on here. So now what we're going to do is we're going to put our rod onto this triple beam, and it's going to find the balance point of this rod, okay? So now what we do is we're going to record the small end of this rod here. Looks like I got a little kink in this thing here. Let's get the kink out of this rod. These things are a little bit on the touchy side here for us. There we go. All right, so 176.2 grams. Now what we're going to do is we're going to take this piece off here. We're going to put it on the scale side down. So now we're going to weigh the big end side of the rod. What we're going to do is we're going to re-zero the scale now. And what we're going to do is we're going to slide this back onto here. Trying not to bump anything or jiggle anything as I'm doing it. It's next to impossible. I want to make sure that I get this as square as possible, because any little bitty cock in here can cause us to get an inaccurate read. Our big end here, we got a weight on our big end, and I'm getting a little bit off here what I measured earlier, so there we go. 446.2 grams. So I must have had a little kink in the rod. So anyway, this was kind of done for a mock-up so you guys can see what all the pieces are that we have to measure. So let's get this thing back up here. Sorry. Zoom me out. So, hopefully you guys can see all these figures here. So now what we do is we're going to do some math on all this stuff. So we're going to take the wrist pin, the piston, the small end of the rod, 2 sets of bearings, or 1 set of bearings, but we're going to multiply it by 2. We're going to take 1 ring pack. We're going to take our oil, and like oil, some guys will add 0.5 grams in, some guys will add 0.4. We choose to add 0.4 grams, and that has a lot to do with what we recommend the oils to run our engine in, by the way that we clearance them throughout the process. And then the big end of the rod, we're going to multiply that by 2. So basically anything that is above piston, ring, piston pin, the small end of the rod with the rings. So let me see how I'm going to explain this. So anything from the center line of the rod up is measured 1 time. Anything from the center line of the rod down towards the crankshaft, you're going to double that figure. And that's how you set your bob weight. Hopefully I explained that well enough for you guys. So the figures that I have, we ran all the figures up on it. From our midpoint of our rod towards the piston, we're at 973 grams. From our center portion of the rod down, we are at 892.4 grams. So now, what we've got is now we've got our bob weight here. Need to re-zero the scale. Whoops, there we go. I'm getting a kick in my scale because I got nuts on here. I'm going to get the nuts off so this thing sets right on the scale here. There we go. 1865. So we're good, okay? It's actually 1865.2. So now let's move the camera here. All right, so now here's the balancer, and there's the crankshaft already mounted up with 3 of the bob weights on. So let me see if I can get you guys a decent angle. This room is a pretty small room that we run for a balance room. It keeps all the dust out of the computer, keeps dust off everything, seems to help us keep everything clean. So now what we're going to use for the bob weight here to install it is we have a basic bullet level here. Let's get this thing up a little more. So a basic bullet level, and then we have our bob weight here. It comes apart in 2 pieces. So what we're going to do is we're going to slide this over the journal. And when we get these nuts started, I'll go over some of the other key features or important factors that you need to do while you're setting your bob weights up. All right, so I've already measured the distance between the journal here for the rod. So where the two rods set on the crankshaft journal, I've already measured that distance out in there. That distance measured out at a 1.900 here. So we had 1.900 thousandths of an inch. My bob weight is 1.450, so just under an inch and a half. So what I would do is I take that 1.450 into 1.900. It gives me a difference of 0.450. So now what I do to set, because I want to get my bob weight dead center of this rod journal here. So what I do is, the way we do it is we go find drill bits. We've got a whole index card of drill bits here, and I found a drill bit that was the right thickness. So in this case right here, we take 450, we divide it by 2, it gives us 225 thousandths. Here's a 225 thousandths drill bit. So now what we're going to do is we're going to put this drill bit between the throw on the crank and between the bob weight here. Now what I'm going to do is I'm going to just snug the bob weight up just a little bit. And let me see here if I can get this thing zeroed out for you guys. So on my computer screen here, let's get you guys over here. It's really hard to see for you guys, I know. So on the computer screen here, I have a part positioning. So what I'll do is I rotate the part on my number 1 rod here to 0. Once I get this rod to 0, which is right there, because all the other ones are set right, so what we have on the other rods is we've got 270 degrees, then we have 180, then we have 90, and then we have our 0. So now what we have is we've got our crank 0 degrees. We've got our bullet level here on top of the crankshaft. So now what I'm going to do is I'm going to put the bullet level inside the center of the level here, okay? Come on. This is a little bit touchy, but you want to make sure to get it right because it does play with your calculations. So now what we're going to do is I want to make sure that I'm still at 0, and I'm not. I've actually moved to 1 degree. So I want to reset this at 0. Recenter the bob weight to inside the bubble level. Okay. Now what we're going to do is we're going to tighten this bob weight up. Get this stuff out of the way real quick. All this stuff is just good and hand tight is all you do. All right, so we're still at 0. We're going to remove our drill bit out of the crankshaft now, okay? And we know that our bob weight is there. So, all right. So now everything is ready to run this crankshaft, at least wise to spin it for a balance. So at this point in time, myself, I always try to wear safety glasses. And they seem like they always have some sort of chew inside my glasses because I'm always chewing. I just can't stop doing that. That and drinking coffee. Those are my 2 sins without a doubt. So what we're going to do now is I'm going to flip this on. And so this is a variable frequency drive that runs a crankshaft. If you guys can see here, we've got a belt that runs down to a motor and it'll spin this crankshaft here. So what I'm looking for on this first spin is we're going to spin this crank up to 350 RPM. So let me see if I can get you guys a little better angle here. this might work a little bit better for you. You guys maybe get a little better vantage point of everything going on at one time. Yeah, this room is real terrible in here, so see if we can back this thing out. All right, there we go. Okay, so what's going to happen is on the computer screen here, there's going to be a meter that runs across in here. When I watch there's a digital tack here that's built into my program. I'll bring this thing up to the right RPM, and then this bar or graph will start to feed, and then it will lock down my RPMs, and then it'll tell us if we need to add weight or not. So let's run the balance and see what happens here. You always kind of want to go into it slow. There's grease that I have on side the end mains. So right there we are at 350 RPMs, right about there. All right, so looks like we got it right there. So what it's telling me is it's telling me on the left side of the crank, which is going to be the back side here, correct? Or am I on the wrong end here? Excuse me. Going to be up here into the front. We are at 168.85 grams is what we need there. And on the back side here, we need 164.93 grams. So now here's kind of a cool little trick that we do for marking this crankshaft. We have a book that'll tell us what size Mallory and what size hole to drill here. But what we're going to do is we're going to take a Sharpie pin here, and we're going to put this Sharpie pin inside the drill press. And when we use this drill press, the only time we'll use this is if we're removing weight out of the crankshaft. We're going to be adding weight to the crankshaft, so we're going to mark this, we're going to take it off, we're going to move it into our tree mill with a fixture that we built, and we're going to drill holes in it to put the Mallory slugs in it. Let me show you what a Mallory slug looks like. So, believe it or not, that Mallory slug weighs 390 grams, which maybe that doesn't sound like that's an enormous amount of weight, but if you think about it, that piston only weighs 500 grams or just over 500 grams. So that right there is almost 2/3 of the weight of that piston. Look at the size difference here, it's amazing. So what we're going to do is on the gauge up here in front of me, we are going to take this crankshaft, and we're going to, if you guys can see this, I don't know if you can. Let's see if I get you guys in here for a little better angle too. All right, let's see. All right, so here is the computer screen, and this is a TNS electronics that we've added onto this balancer. It is absolutely the neatest damn thing that we've ever used for balancing. So that'll go green. There's a little triangle right there, if you guys can see that on camera. This is going to go green when I'm in the right spot. Well, it should go green when I'm in the right spot. Let's see here. There we go. Let's see, come on, right there. Okay, so right there is where I'm going to want to put the hole. So what I'm going to do is we'll back you guys up here a little bit again. We've got our drill press here with our pin in it, right? So what I'm going to do is I'm going to take this thing, and now we've got our marked. We're just going to take this thing and we are going to put a mark right across that main, just like that. So we know that this is going to be the area that we are going to remove the material out. Now, we'll weigh a piece of Mallory. We can move it to the center if it weighs too much, or move it to the outer edge to get more or less Mallory. So now what we're going to do is we're going to get into the green here for our front counter throw, which is right there. Hopefully you guys can still see this. And now what we're going to do is we're going to mark, there we go, we're going to mark the front counter throw. So now we know exactly where we need to put the Mallory in this crankshaft. So now that's about the end of this video here for you guys. Let's get this thing back out of here and do a little talking for a minute. So I know we ran through that pretty quick because that was a pretty quick deal. So I'm not going to take any of the bob weights off of it. The fixture that I've built inside for the mill, we can run the bob weights on it, so we won't have to remove the bob weights. Right now we did our first initial spin. We know how much Mallory we need to add into it. We'll go to the chart, we'll figure out if it's in a 1-inch piece or 1 1/8 or 1 1/4 piece. Do a little bit of math, and then we'll go drill the holes. That'll be the second part of the video. Hopefully you guys watch it and like what we're doing. Please don't forget to hit the subscribe button and hit the bell. That way you guys get notified when the next videos come out. Thanks for watching. Eric at Redmond's Performance.